Hey guys, so this video is going to just be going over the beta oxidation cycle. And I'm just going to start with the palmitoyl-CoA group. I'm going to assume that the palmitate's already been activated, and that's the step before the cycle begins. So I'm not going to write out the whole chain, I'm just going to write R12 for the 12 carbons before the rest of the chain, and then this is our palmitoyl group, palmitoyl-CoA. So here's palmitoyl-CoA, and I'm going to be labeling the alpha and beta carbons because they take place in most of the reactions and they're the most important. Now, this whole cycle can be kind of overwhelming at first if you've never seen it before, but if you break it down by structure, not that much is really going on. So just thinking of it in terms of what's happening with the bonds really helps make this very simple. And sometimes you'll see this as palmitoyl, and sometimes it's palmitoyl, and those are the exact same thing. So this is the first step here, and I'm just going to be writing this in a downward ways, and then we'll cycle back up to the end, because you can really see how slight the changes are between the reactions. So this first reaction, we've still got our 12 carbons, and we've still got this here, but between the alpha and beta carbons, we actually now have a double bond, and I will write that in a different color for you guys. So this is going to be a double bond between the alpha and beta carbon here, and this is our dehydration, or excuse me, it's our oxidation step, which is, it is a dehydration, but it's also an oxidation. So here's alpha and beta carbon, and then I will write in, so it's being oxidized by FAD in this case, and this goes to FADH2, and then the enzyme that's doing this is just called acyl-CoA dehydrogenase. And all of these enzymes in the cycle are named after their substrates. So an acyl group, an acyl-CoA group, is going to be a chain of carbons with a CoA attached to them, where there'll also be acetyl-CoA, which is, instead of a whole chain, it's just one carbon attached to a CoA group. And it's kind of obnoxious because the slight difference there actually means a difference, while you can have palmitoyl and palmitoyl, and those aren't different at all. But the most important thing to know about this is that it's an oxidation step. And then in this oxidation step, you're just losing two hydrogens, and they're going on FAD to FADH2, and it forms a double bond there. Now, and this compound that's created is called trans delta 2 ennoyl-CoA. Now, this next step, we still have our 12 carbons in the chain, and then, but the double bond is broken in this step, and everything else stays the same, except we add on a hydroxyl group right here. And believe it or not, this is called dehydration. And even more surprising, when you're doing a hydration, you need water. Totally unbelievable, I know, but it's science. So this step is a hydration, and the enzyme involved with it is pretty amazing as well. It's ennoyl-CoA hydratase, and it has an alternate name as well, just chronotase. And I will label our alpha and beta carbon here because it's important to keep track of those as we go along. Now, following our hydration step, and this gives us the compound with a kind of annoying name of L-beta hydroxyl, or hydroxy rather, hydroxyacyl-CoA. And beta for beta hydroxy for the hydroxyl group being on the beta carbon. Alright, third step, we still have our 12 carbons on the chain. However, the big difference now is that that hydroxy group is now a ketone. So it has formed a double bond and gotten rid of the other hydrogen, and this is also an oxidation step. And I will label the alpha and beta carbon again, just for continuity's sake. And the oxidating element here is NAD plus this time, instead of FAD as before. So NAD plus goes to NADH, and then there's another hydrogen in there because we had 2 extra hydrogens. And this is done by an annoyingly named enzyme called L-beta hydroxy acyl-CoA dehydrogenase. And there's no alternative name for this. I'm sure there is, but we just don't know it. Okay, so that's that, and thankfully the name gets simpler for this compound. This is just beta-keto-acyl-CoA. Fairly straightforward. Now the final step is where things get interesting. So we've got our beta-acetyl-CoA, we've got these double ketones going on. So now we cut away at the alpha carbon here. So this is 12 still, but now this is only 10, and everything shifts down. So this becomes our new alpha and beta chain, which used to be part of this chain here. And this pink ketone here becomes our new precursor to the alpha beta carbons. And a new CoA group gets added here. And this is done with the help of CoASH. And I will label the new alpha and beta carbons that are involved. And the enzyme for this, also simply named beta-keto thiolase, or just thiolase. And this is the thiolysis step, or thiolysis if you like. And this compound is now myristoyl-CoA or myristyl-CoA. And myristyl always reminds me of mithril for some reason, so I'm going to call it myristyl-CoA for all of my Lord of the Rings fans out there. And then along with this myristyl group being formed, we're also getting an acetyl group, acetyl-CoA, which looks like this. So we now have all the steps in our cycle, and then this myristyl-CoA can be taken and it goes back to be oxidized again by FAD and the acyl-CoA dehydrogenase. And so that's all the steps of the cycle, and as you can see, it's really just a matter of you get a double bond between alpha and beta carbon, then you get rid of the double bond to add on a hydroxyl group, you form a ketone, and then you cut it off here for a thiolysis, and that's all there is. And so just follow the pink lines, and it's not too bad at all. And of course, I'll do a summary for you guys, and this will be Star Wars style here. So first, you've got your acyl chain, which loses 2 carbons, and in the process of doing that, you get FADH2, NADH, and you're in acetyl-CoA, and you use those to go back either into the electron transport chain or into the TCA cycle. And then the acetyl-CoA that's going into the TCA cycle makes more FADH2 and NADH and ATP to even get even more ATP. So you can see how a fatty acid is very energy dense, and you can get a lot of ATP from just the breakdown of even just one fatty acid. So in this case, we were looking at palmitoyl-CoA, and we had 7 FADs and 7 NAD pluses. And you go through 7 cycles of it, because once you get to the last cycle where you have 4 left, you just cut that in half, and you've got 2 acetyl-CoAs. So you don't need 8 cycles, even though you would think, snap judgment, you would think, oh, well, it's 16 carbons, so I need 8 cycles, but it's 1 less than you would think. And then you end up with 8 acetyl-CoA groups, and 7 FADH2s, 7 NADHs, and 7 extra hydrogens. So that's the entire beta oxidation cycle. I hope it helped you guys. My name is John, and I wish you all way more than luck.